Welcome to our presentation of discovering HTTPSified phishing websites using the TLS certificate footprints. My name is Yuji Sakurai. This is a joint work with NTT Secure Platform Laboratories and my professor, Tatsuya Mori, Boston University. Here is the outline of our presentation. We'd like to start by talking about the background. In this research, we focus on digital certificates to detect phishing websites, and we'll talk about some reasons. Digital certificates are necessary for websites with HTTPS, and the number of such websites has been increasing recently, but we can see the same trend on phishing websites. This graph shows the percentage of phishing websites with HTTPS for each quarter, and you can see that the percentage has been increasing greatly, and now over 70% of phishing websites adopt HTTPS. There are other reasons we focus on certificates. Certificate-based phishing detection approach has several advantages compared to traditional approaches. This figure shows the general process of phishing attack and which phase of the process each traditional and certificate-based phishing detection approach work. Detection approaches based on URL, web content, and email are classified as crawl or query-based approach, which have the disadvantage that in most cases, they work only after phishing is done. For example, after spam emails are delivered or the websites are published. In contrast, domain registration and certificate-based approach can detect phishing in preparation phase, in other words, before the phishing is done. However, domain registration-based approach don't work well if the attackers use DDoS or hosting services, which we've seen a lot recently. The reason for this is that the approach can only look at TLD and second-level domain. But we can look at FQDN of a website if we use certificate-based approach, which means that the approach will work if the attackers utilize DDoS or hosting services. From this, certificate-based approach can compensate for the shortcomings of traditional approach, so we focus on certificates for discovering phishing websites. Therefore, the research question of this research is that is there a way to discover phishing websites using information on certificates? To answer the research question, we focus on common name, which is almost identical to FQDN, and propose a framework to discover previously unknown phishing websites. First, we collect certificates used for phishing websites and perform clustering with DBScan on the common names to get groups of certificates with similar common names. Next, we extract templates, which are regular expressions of a common name. The templates play an important role in this research. I'll explain how to extract them later. Finally, we search certificates that match the extracted templates in the wild, as we consider such certificates are likely to be used for phishing attackers. Here is an example process of clustering. You can see some common names of certificates on your left side. Through clustering with DBScan, we can group certificates with similar common names and eliminate ones that are not similar to any of those groups as outliers, as shown in this figure. We'll make a brief explanation about how to extract templates. Let's suppose we have two certificates with these common names in a cluster. In other words, group. First, we extract substring common to those common names. In this example, it's -account verify, and convert the strings other than the common substrings to regular expressions like this. Then we combine them together into a string. At this point, we combine the minimum and maximum lengths of the regular expressions. Also, we eliminated templates that are too generic to use. For details on that step, please see our paper. We collected the following data. In this research, we utilized OpenFish to obtain phishing URLs and census database to get certificates those phishing websites used. We obtained 1,634 such certificates and 69 templates through the method I described in the previous page. Also, we collected 38 million certificates in the wild, which were issued by Let's Encrypt or cPanel, as many phishing attackers get their certificates from those two certificate authorities. We use them for searching certificates that match the extracted templates. The survey period is about 3 months from October 2018 through January 2019. Let's look at the detection result. This table shows a summary of the phishing detection result. We obtained 1,650 certificates with common name that match one of the extracted templates. We found that there are 1,049 certificates with unique common names, in other words, unique websites. And 90.8% of them were flagged as malicious, which means at least one antivirus software raised alert. Moreover, of the detected certificates, we found that 24.8% include domains provided by DDNS or hosting services. And the 1,049 websites were likely not to be listed in OpenFish at the time their certificates were issued, so they were previously unknown at that time. These results demonstrate that our framework is useful and effective to discover phishing websites at the earlier point in the phishing lifecycle. Here, we found a case where a template matched a large amount of certificates in the wild. This template contains a string, RuneScape. Some of you may be able to recognize the string. It is a very popular multiplayer online role-playing game. The certificates the template matched accounted for 56% of all detected certificates, and 93% of them were issued by the same certificate authority. Let's encrypt. From these characteristics, we speculated they were issued automatically, and there are some phishing kits that target RuneScape. So we searched forums on the internet. As a result, we were able to discover a phishing website generation service that obviously targets RuneScape. We were surprised to find that the service offers many advanced and useful features, such as mass mailer to send a large number of customizable phishing emails, logging, analytics, and marketplace where you can sell or buy stolen credentials. In terms of the research ethics, we registered for the service to research, but we didn't use any of the provided services. This is an example of a fake login screen a user could make. From this case, you can see that our framework can contribute to understanding the phishing infrastructure. Finally, we'd like to summarize our presentation and touch our future research. To summarize, the key takeaways of this research are the certificate-based phishing detection approach we proposed can discover previously unknown HTTPSified phishing websites, while compensating for the shortcomings of the traditional phishing detection approaches. In addition, it can contribute to understanding the phishing infrastructure. For our future research, we plan to establish a real-time monitoring system that uses the framework to overcome some limitations we faced. For example, we were not able to visit the detected phishing websites because most phishing websites are short-lived. So the real-time monitoring system allows us to evaluate our framework more precisely and discover phishing websites that are not in blacklist in a real-time manner. This wraps up our presentation. Thank you for listening.